The topic that I'm going to discuss is all about the main memory and some of the memory allocations, but I am just talking on the first part of the memory management, which is until segmentation, and my companion will discuss some of those memory management scheme. So prior to my discussion, let's have first the background of what would be the main memory. So as we know, the program, if we are going to execute or invoke the program in the local disk, it will be fed into the memory and placed within a process to be run. So for the information of everybody, I am referring to main memory. I am referring to RAM as the main memory in this discussion. So the main memory and registers are the only storage that the CPU can access directly. So because even though there are a lot of memories available in our system unit, but since it matters on the cost, so technically the main memory and the registers are the only CPU storage are the only storage that the CPU can directly access. So the memory unit only sees a stream of address. It's a series of address, but that address is composed of an addresses plus the request, or it is composed of address plus the data of that address and the right request. So the registers access in one CPU, in a CPU per clock cycle. So meaning to say the access of the register is per clock cycle or less. Now, the main memory can take many cycle causing is a stall. So stall is referring to overloading. So if a bunches or a large voluminous number of data will be loaded of the main memory, but since main memory is just only a volatile type of memory and it only holds a specific length of it only has a capability of a specific length of data, small amount of data. So there is a possibility that an overloading occurs. Now, the question there is, how does this memory can be managed to prevent such overloading? Another thing is, how does this memory how does the system prevents colliding of information inside the main memory? So those questions will be answered later during my discussion. So cache sits between the main memory and the CPU registers. If you are going to look into the architecture of the central processing unit, so the cache sits between the main memory and the CPU. Cache serves as a temporary memory in which the CPU can directly access a specific length of time. So therefore, only those valuable informations, those commonly accessed informations are located in the cache. So those only usable or those only commonly used informations are being resided or to be resided in the cache, and the rest of those informations will reside in the main memory. Okay, now for us to understand on how to prevent collision and the proper way on the memory allocation, the management of the memory allocation inside the main memory or the RAM, let's try to consider on this illustration. So assuming that I have a base. So by the way, so the means of memory management is by creating a logical address which used to manage efficiently the memory in the main memory. Now take note that in the later on in this discussion, I will be differentiating the difference between the logical address and the physical address. But for this moment of my discussion, I will be dealing with the logical address. So assuming that in my logical address, it is composed of a base and a limit. So the base is the location exact location, or the location of the memory, or shall I say it is where the starting point of your data to which it will reside in your memory, while the limit is the capacity, the extent capacity of your data, or shall I say the maximum memory allocation for your data. Now, in creating a logical address, there must be a base and a limit. So, for us to identify, or for us to differentiate, or to give an outlook on how does memory management takes place in your main memory, particularly on dealing with logical address, let's try to discuss on the hardware address protection. So assuming that I have a base of information, I have an information with a base of 200 and a limit of 600. So approximately the information will reside in the main memory starting from 200 up to 800. So assuming that the CPU, will assuming that the CPU will access information in the main memory having a base of 300 and a limit of 200. So your operating, or your main memory management unit, or the MMU, which I'm going to discuss later, will shall I say, perform the following operation. First, it will check the base address. If the base address is greater than or equal to the specified base address. Now, in our assumption, we have a given 200 base address, and the base address of the logical address in which the CPU will access is 300. So based on the condition, since 300 is greater than 200, therefore, in checking the base address, it passes through the check on the base address and proceed to the second condition, which is the base plus the limit. Now, if we're going to add 300 and 200, it approximately provides 500, which based on the illustration, that 500 is less than the base plus limit of the assumption or the given memories in the main memory. So therefore, it passes a certain condition. Now, with that, the main memory, or the memory management unit, will allow the CPU to access the memory in the main memory. If those conditions will fail in, it will fall as a trap to the operating system and provide an addressing error. So this is how your main memory, or your system will manipulate memory allocation in the main memory. Okay, so the process of adding those base and limit in order to provide a logical address is what we call address binding. Now, binding of instructions and data to memory happens in three stages. We have the compile address binding, the load time address binding, and the execution time address binding. Now, we will have to differentiate these three based on this example. When a certain program is being executed, it will be compiled by your compiler and your assembler. And when the program is being compiled by your compiler and your assembler, it is now on the stage of what we call compile time. So compile time, if the memory location known a priori, an absolute code can be generated and must be recompiled, and I must recompile code if starting location changes. So what does this absolute code means to? Now, the absolute code is the amount of main memory needed by your process, by your program, in order for it to be entertained, in order for it to be processed. Now, assuming that I have a program which requires a 4 KB main memory. Now, that 4 KB main memory needed for that program during the compile time is what we call the absolute code. Okay, we will proceed to the load time address binding. Now, the load time address binding, when those programs being compiled by your compiler, it will generate an object module. This object module will then be linked with other object module. If your program is, shall I say, an object-oriented type, will link with other object module using a link editor. And this link editor will be loaded in the load module for it to be compiled again with this what we call system libraries. And what are these system libraries? System libraries are those programs that you have declared prior, such as stdio, conio.h in your common C++ program. Okay, so load time must generate a relocatable code if memory allocation is not known in the compile time. Now, during the compile time, as we know, that only asserting or only the amount of memory necessary is already known, but the relocatable code is not yet known. So during the load time, this relocatable code will be generated. Now, how does this relocatable code looks like, and what is the purpose of this relocatable code? The purpose of this relocatable code is for you to have an approximate memory allocation based on the amount of memory needed by your program. So, assuming that I have a relocatable code address of 2000 and my memory, my program needs a 4000 or 4 KB memory. Now, in order for me to have or to map this into an exact location in the main memory, I must have first generate a relocatable code address, assuming that the relocatable code address is 2000. Now, I will have to add this 2000 on the allotted memory, makes it 2000 as the starting point of my program in the main memory, and it ends with 6000 as the last point in where my program will reside in memory. But take note, don't be confused that this is just only a logical address. Now, this logical address will later on be converted into a physical address by the memory management unit. Okay, so let's proceed to the execution time address binding. So the execution time address binding delayed until runtime if the process can be moved during its execution from one memory segment to another. So it needs hardware support for address maps such as base and limit, example, the base and limit registers. So what does this mean? Now, during the execution time address binding, those logical address can be converted into a physical address prior to its conversion to its physical address. Why does it is moved into queue? It is moved into queue prior to its conversion. That is because during this execution time, your memory management unit will look for a reference in your main memory. This reference will serve as a specific address in your physical memory that will be bind again in order to provide a physical address, a real physical address in which your main memory can understand, in which your main memory can be read. Now, take note, during the compile time, during the load time, only the logical address was generated, but in this time, in the execution time, it is now on the process of converting this logical address into a physical address by having an exact reference address which was being processed by your main memory unit. Okay, so let's have to differentiate what is the difference between a logical and a physical address. So the logical address, the concept of logical address space is bound in a separate physical address space essential to property memory management. So we have two types of address space. So we have logical address, which is generated by your central processing unit, and the physical address, which is an address being seen by your memory unit. Now take note, the logical address is generated by the CPU while the physical address is seen by your memory unit. Logical and physical address are the same in compile time and load time address binding, while the logical and physical address differ in execution time address binding, because in the execution time address binding, your logical address will be converted into a physical address using a reference or relocation register. So logical address space is a set of all logical addresses generated by the program, while the physical address space is a set of physical addresses generated by your program. Now, I've mentioned a while ago the word memory management unit, because this memory management unit is very essential in converting your logical address into a physical address. So a memory management unit is a hardware device that at runtime maps a virtual or a physical address into a virtual or logical address into a physical address. So the start consider a simple scheme where the value in relocation registers is added to and every address generated by user process at the time sent to the memory. So this base address now to be added, or reference address now to be added in your logical address, is what we call relocation registers. And these relocation registers will be generated by the memory management unit. Okay, so the user programs deals with the logical address if never sees the real physical address. So execution time banding occurs when reference is made to location in the memory. So logical address bound to physical addresses is bound to a physical addresses.